All right, so on to the next session here. So the next one we have is the OSD review. Primarily, it looks like we're going to focus on the backend discussion for Kinetics, RocksDB, some of that work that's going into it. I don't think there was anything else as far as the review goes, but I do know that we have some discussion later on in the day that's about the new work that's coming. So if you want to give us the review, Sage.
Sure, I can give sort of the high level thing if and Sam or Josh, if either of you want to chime in too, that'd be great. So there's a bunch of stuff that we proposed originally during the Giant Summit. And then there's a bunch of other sort of work that was in progress people were discussing on the mailing list. And a lot of it was just around the backends for the OSD in general. So I wanted to just sort of highlight the work that's in progress, where it's at, and where it might be going. So the first is that just to sort of level set, remind everyone that the way the OSD is architected, there is an internal abstraction called Object Store. That's the interface that the OSD daemon uses to talk to its local storage, usually a file system and disk or whatever that's attached on that node. That sort of cleanly encapsulates everything it needs to do to store data locally. And there's currently one implementation that everybody uses for that. It's called File Store. And that's sort of the piece that stores objects as files, usually in XFS, but also can do Btrfs or ext4, and the piece that it has that journal that we're normally putting on SSD. So it's the thing that's responsible for managing that local disk. But the nice thing about that interface is you can plug in alternative backends that implement things differently. So one of the things we added maybe 3 to 6 months ago was memstore backend. So there's one config option that you set, OSD object store equals memstore. And that's just an in-memory thing that's doing all that storage. So you can start up the OSDs this way, and you can do sort of this, you can do benchmarking mostly in validation to see how the cluster would perform if it had sort of this infinitely or DRAM speed backend. Just is useful for benchmarking and some other things. And as also just as a reference implementation for what the backend sort of has to do in order to be functional. The second backend that was, or third, I guess, backend that was added recently from Hao Mai Wang at United Stack was a key value store implementation. And the idea here is that basically everything that you're putting into the OSD that is storing locally is just dumped into a key value store like LevelDB. And all the data lives there. The idea is that for certain workloads, that's just going to make more sense since most of the data is key value based anyway. For example, the Rados gateway has a separate pool that it's storing the bucket indexes in, essentially mapping the name of the bucket to all the objects that are stored within it. And it has random insertions and updates and so forth. And if that's sort of the workload, then just dump all that in LevelDB. Don't bother creating individual files in the file system. And things will be better. And the nice thing also about that interface is it has LevelDB in particular has a transactional interface. You can say update these 37 keys, and it will atomically do that in an efficient way, which matches very well the semantics that our object store interface has. So you can get rid of that journaling weirdness that the file store does. So that went in a while ago, and Hao Mai's been doing various work to improve performance and test it and tweak it and so forth. So that's been fun. Sort of the other thread of this though is that the interface that we use to talk to that key value store also has an abstract sort of wrapper in Ceph land, and that's called key value DB, I believe. And that's just a thin wrapper around LevelDB's API essentially. And so there's another branch outstanding right now called WIP-RocksDB that takes RocksDB, which is a different key value store that came out of Facebook, that I believe actually was based on LevelDB originally, but is optimized specifically for Flash SSD stuff, and it's supposed to be super fast. And if you look on Twitter and whatever, everybody's all excited about it. It's super fast. But that's about to land. Actually, I think it might even be ready. And so then that means that you can sort of also have a configurable where you can say, don't use LevelDB to use RocksDB instead. Use this other key value backend. And that'll work both for the key value store, which is sort of storing everything inside that key value DB, or it could also be used on top of within the sort of existing file store context where you're still using files. because we still have LevelDB there. We just use it for only a few different things, but you could store those few different things in RocksDB instead of LevelDB. So that's in progress. That'll be the second key value backend. And the idea then is you can sort of slot in others depending on what makes sense for your workload or what sort of long-term ends up being better. So then at the last summit, we had a session about the Seagate Kinetic drive, which many of you have probably heard of. It's a hard disk, which instead of having a SATA SAS interface, has a Ethernet interface. So the drive gets an IP address. It's got a little ARM processor running stuff on there, and you talk to it over TCP. Instead of having, so they changed two things. One, it's Ethernet, and the other thing is that instead of sending block IOs to the disk, you send key value IOs. So internally on the disk, has sort of a key value database that's all sort of cute and well integrated with the disk firmware, presumably to do it all efficiently and so forth. So Josh did some patches that would essentially implement our key value abstraction on top of the Kinetic API. So you could run our key value store thing backed by Kinetic instead of LevelDB or RocksDB. And those patches are also not merged yet, but sitting around there. They're mostly complete. There are a few sort of rough edges because of we're using like the C++ API, and it required C++ 11, which we don't build everything with yet because it's not supported on a lot of older distros. And there are some issues with the iterators, like reverse iterators being exposed through the C++ API, and so we're working around that in some annoying ways. But there modulo some sort of annoying issues to get cleaned up. That's mostly ready to get pulled into the tree just as sort of a second reference or third reference backend implementation that people can play with. Not recommended for production use yet. You can't even buy these drives yet anyway. But as sort of an experiment to see so people can play with it and see what kinds of workloads and so forth make sense on this particular class of Ethernet drives. Josh, is Josh here? Does Josh want to talk about the Kinetic stuff at all?
I don't see him.
I don't think he's here yet. Oh, there
he is. Yeah, give me a second. I'll get him on.
Okay.
I had a couple of questions coming in.
Sure. Yep.
Asking about the OSD processes running on the Kinetic ARM.
Yes. So the current generation of Kinetic as is doesn't let you run your own code on the disk. So they wanted, my understanding is they wanted to sort of have a new standardish interface, open up all the APIs so people can consume that interface. But it's really about like, what's the next generation of disk interface supposed to look like? Kinetic, go use that instead. So you can't run the Ceph OSD on the ARM. There are other hard drive manufacturers who are making Ethernet disks that do let you run whatever code. So HGST made this big announcement at OpenStack where they have their version of the Ethernet drive that has just a general purpose ARM processor with a couple gigs of RAM and a couple cores, maybe just one core, I can't remember. But it's like running Debian or something. You just like install the OSD on there, the ARM build, which we did a bunch of work last year that already all works. They didn't actually barely talk to us. They just installed a Ceph, and you could run Ceph on the disk. So you can imagine these data centers that are just full of racks and racks of disks and shelves that are plugged directly into Ethernet for cold storage. It's pretty cool, eliminating sort of the host entirely. Just sort of what we were thinking when we designed Ceph and called them OSDs, object storage devices. That would actually be a device. So yes, so that's happening. For those drives though, they're not doing anything weird with the disk interface, so it's still just a block device. And so on that little ARM chip on the disk, you still have to run XFS or whatever. So I think there's still a lot of room to sort of improve that situation. But I think again, sort of broad strokes, this work is really about making it clear that there's room to plug alternative backends into the OSD and to experiment with them, as long as you can sort of satisfy the basic API that everything else is relying on, basically pushing transactions down that store objects and keys and values. And I look forward to seeing other people sort of, try to plug things in and see how they can optimize. The sort of the reference implementation, the file store one that everybody uses, is something that we arrived to incrementally over many years, and works well and is sort of well tested and robust, but isn't always the most performant and isn't necessarily what you would sort of end up with if you started with a clean slate. And so people should put their thinking caps on, I guess, and see what else makes sense.
Josh has arrived.
Josh is coming. Yep.
Hey, Josh.
Yep.
I think everybody's muted by default, so you'll have to unmute yourself.
Yeah. Do you want to say anything else about Kinetic? What the status is there?
Oh, there we go. Oh, there we go. I didn't hear the first part of it, unfortunately, but basically,
okay.
There's like a prototype backend that I'm going to push to a branch later this week, which uses the existing key value store interface and the key value DB interface, and just implements that in terms of the Kinetic API, talking directly to the Kinetic backend from the OSDs. It doesn't do a whole lot special right now. It just does the basic operations, directly translating them, and currently implementing iteration on top of the Kinetic API, since it doesn't provide efficient backwards iteration.
Cool. Okay. Let's see, the other piece. I think the other big branch that's sort of waiting to merge is the WIP-RocksDB, which I believe is mostly ready. It's been...
Yeah, I'd actually included it in my Kinetic branch too, so I could get all the options set up for supporting both different backends.
Okay. Yeah, I think we just need to make sure it builds in the Git builder, because it's pulling in RocksDB as a submodule, because no distros have packages yet, and we want to actually make it usable. So for the time being, the submodule, and we had to somebody, Jinshin at where she was at Intel, I guess. I'm probably butchering the name, sorry. Yeah, so it's all automakified, so it just needs to be linked into the build system. And
yeah, and for both RocksDB and Kinetic, they both need C++11, so they won't build in older systems.
Yeah, but it's fine. These are sort of experimental features anyway.
Right.
Did we get Loic's question answered? And he was asking about whether or not it'd be useful to version and maintain the OSD protocol, encourage alternate implementations.
So there is a bunch of versioning that does happen already in terms of whenever OSDs are communicating with each other, their feature bits, and they sort of avoid sending certain messages to their peers that they know they don't understand. That's just the basic step that we have to do to make it so we can do rolling upgrades in the system. There's been no attempt to do anything that's drastically different than the sort of the current implementation now, as far as making like a very simplified Rados or something like that. I'm not sure that there'd be too much value or practicality in that particular ad.
So we also have a question from one of our guests, asking about how bad is the Kinetic performance. Do we have any early kind of gut feelings on Kinetic performance? Have we played with it enough to even know that much?
We haven't really played with large enough clusters, I think, yet to know how it would do.
Yeah.
And since it's kind of at the prototype phase right now, where it's actually not using the efficient iteration that the API would provide if it used the entire protocol.
Right.
It has some bottlenecks there already, which are not actually inherent in the protocol.
Right. Yeah, the current version is slow, but for very obvious reasons.
Right.
So due to no fault of Kinetic, but just the way that it's currently being linked in. Yeah.
Cool. Sounds like we're about halfway. Did you want to hit on the rock stuff now?
And let's see. We talked a little bit about that. I think it just needs to be.
was there a blueprint from that, or did we just kind of wing it?
I don't think so. I think it came in over the list. That's my understanding. I don't know, Sam, is there anything else you want to talk about as far as maybe not backend specific, but just stuff that's in progress on the OSDs?
So the other notable thing that happened since the last summit would be the threading and parallelism improvements in the OSD from Greg, the MSFest dispatch stuff. That's cool. We were looking as in librettos to improve OSD throughput on high IOP workloads. So there were a bunch of changes made to the way the OSD dispatches messages to decrease the CPU overhead and improve locking.
And the goal here again is high IOPS workloads with Flash backends, so sort of the driving use case. Although in general, I think it'll help in other cases too. Do you have a sense of how much progress we made on that? Like, I think any sort of absolute numbers are going to depend on what kind of hardware you're using and what backend you're using. But I mean, do we like double the IOPS or?
I think it was more, but that may have included some work that hasn't gone in yet.
Okay.
It was quite a large improvement, actually.
Yeah. Okay. So it's probably worth mentioning. Yeah, this is all post Firefly, as far as when all this went in. So there was a piece that that changed the way that the messaging layer that's pulling stuff off the network hands off those ops to the OSD, and then there's a piece that makes the work queue that's processing those behave better when you have lots of different cores.
Right.
I still get the sense that if you just run everything through a profiler, there's probably some just general stuff where we're just wasting CPUs copying stuff around. But I'm not sure how much that was actually the case, or if those sort of easy things have already been resolved.
I believe there's still some low-hanging fruit in that regard in the file store, but probably somewhat less than expected.
Yeah.
Mark had a comment here. Said, from what he's seen with RocksDB, it's helpful regarding allowing parallel compaction and on the read side, more consistent memory usage and performance by not using a map. I just wanted to comment.
That's actually interesting. I didn't know that it was on that.
So I have this thing in my head that RocksDB is specifically targeted at SSDs. Is that true? I think is that true? Can somebody confirm?
I didn't think so. I thought it was that Facebook's modification?
Yeah, it's Facebook's thing. Yeah. I thought it was specifically focused at. Well, I'll go look at the homepage. Maybe I've just been spouting nonsense for the last. To efficiently use fast storage.
Say, can you hear me?
Yeah, now I can hear you. Yeah.
Their GitHub page actually says
sorry. Michael's
persistent key value store for flash and RAM storage.
Okay.
I think they say that, but it seems like they're basically they looked at level DB and we're seeing like 99 percentile latencies that were super high, and we're like, screw this, and tried to improve it and make it better in general, from what I can tell.
Mm-hmm. Okay. Yeah, the nice thing about from what I've seen the RocksDB backend, it was almost a search and replace of the LevelDB one, because I think they started with LevelDB, or at least adopted the exact same API. So it sort of slots in easily. There's another project called HyperLevelDB out there where somebody else did their own set of changes to LevelDB. I think mostly around threading, where they wanted lots of cores dispatching transactions, and I think LevelDB sort of piles it all up in one thread. So that would be another one that, for the same reasons, would be sort of trivial to slot in and do experiments with. So for people who are interested in this stuff, the more the merrier, as far as I'm concerned, as far as getting these back in so people can play with them. As long as you're sort of careful about knowing which ones you want to run your production data on.
Was there anything left to talk about from the other two blueprints that were left over from Giant, the PG temp stuff and the new cache modes?
No real progress has been made on this. So on the PG temp mapping stuff, when we discussed it last time, I think we had a pretty good view of what we needed to do in the monitor, but we're sort of focused on general performance and stability stuff right now. And the second one, the new cache modes, there is the one cache mode that I think that is going to make it in for Giant is the what's it called, read forward. And the idea there is when you have a hot and a cold tier and you're using Rados caches and the object is not existent in the cache tier, but it's a read, you're better off just forwarding that to the base tier and reading from there and not promoting it to the cache tier, because apparently with high-end flash and low-end flash, or that's probably a very imprecise term, but basically the flash that's intended for colder storage can't do as many write cycles and tends to be slower on writes, but it turns out the read performance is essentially the same as the good stuff. And so forwarding, if it's a read-only event, just forwarding it to the cold tier and reading from there is just as good. So that's a relatively simple change. Luis, I went over it with Luis last week or the week before, so we might get that in soon, and if not, whatever. But I think that one's gonna land in Giant. It's a pretty simple change actually to add that additional node. The second one that we were talking about was would actually proxy the read through the cache OSD, and so you don't go back to the client and sort of redirect. That would be a little bit more complicated, and so I'm not sure. I think until we have sort of a clear demand for it, probably not worth doing that work.
Gotcha. There was one question here that's a little off topic, but still OSD related. Wanted to know about RAM usage of OSD processes, if there was a way to hard cap their RAM usage.
Wouldn't that be great? There are a bunch of different caps that limit different parts that consume memory, but there's no sort of total cap on the process, unfortunately. So that's actually sort of going forward in general is something that we need to do a better job of, is figuring out how to ensure that the OSDs don't get too carried away. Particularly if we want to talk about using this new generation of Ethernet drive where we're running the OSD on the disk, and you sort of have this much more constrained environment where there are only a couple gigs of RAM probably. You need to be quite sure that you fit within that and don't sort of dig yourself into a hole, because it will be challenging to get out of it.
Would C groups be a good intermediate step there?
Yeah, I think C groups, or even just U limits. I mean, you can always just set a limit where it'll kill the process if you hit it, but that doesn't necessarily. Yeah, that'll help in some cases where it's sort of a temporary runaway situation, and if you restart, it will not hit that same limit again.
Right.
I think that the things that worry me is if you have situations where the data distribution changes such that suddenly some set of OSDs are mapped to a whole bunch of PGs, and in order to go through all the current peering and recovery stuff, even to just sort of again shed that responsibility back off to another device, they have a lot of work to do. So we need to figure out a way sort of at the macro level to make sure that we don't pick on individual devices.
So there's another question coming in here about whether or not we've considered anything for an OpenNVM backend for the Fusion IO stuff.
We've definitely talked about it. So I'm blanking on OpenNVM, but the Fusion IO API is NVM KV. I don't know if that's the same thing. Oh yeah,
yes, he linked it. Yeah.
Yes. So one of again, with all these key value backends, we have this sort of internal interface that we use that wraps the individual backend that we can then map onto it. So the goal with the Kinetic work also was to get something that'll work on a generic key value store, and then so you can sort of plug in other ones easily. So I would love to see a set of patches that just wire up the NVM KB interface. The one challenge there is that our key value interface is transactional. So you define this arbitrary transaction of updating a bunch of keys and values, and the backend has to do that atomically. NVMKV has a useful thing called batch put that will do a bunch of key values atomically, but it has a limit of like 50 keys or something. So we need to have sort of a shim layer that will use that if the transaction is small enough, and if the transaction happens to be too big, then we fall back to some less efficient thing like, writing it, encoding the entire transaction and writing that in a sort of write-ahead base. And then once that's durable, then applying it and then cleaning it up, that sort of thing. Sort of the same write-ahead tricks that we do with the file system. But I think once we have those two pieces in place, then we'll have all the sort of necessary ingredients to plug in a bunch of different backends, which would be pretty cool. I'd love to see the Ceph OSDs running on that Fusion IO interface. I think it'd be great.
Cool. Matt had asked a question from a few minutes back. Which branches changed the OSD work queue threading?
That was, I don't know, Sam. What was that?
Oh, Greg just answered it.
Yeah, sharded thread pool. Yeah.
Yeah, it's just in master now. There were external branches that got merged in.
Mm-hmm. Yeah, Mark mentions that he's done a bunch of testing on the different variants of LevelDB. Basho has their own fork too. They all behave a little bit differently. So, yep. Right now we're just using stock LevelDB and a slightly old version at that. Cool.
We've got a few minutes left in the session. If there are any other questions, now's the time. Otherwise, we're going to be moving on to the RBD review here. So give people a few minutes to type their questions if they prefer to do that. All right, well, let me switch the video over here, and then we'll get started with RBD.